Let me try to explain some basic idea about polymorphic functions now, and then I can give you some homework to play with some of these things. So it's not going, I'm not sure, we'll see. If you find the homework too hard, I can explain it again next time or add some more data information about it. But I kind of want to, because it's going to be very, very short, I think. So okay, let's see, polymorphic functions. What's this? Okay, so we already kind of wrote a couple, so that's why I'm trying to, like, I'm not making a big deal out of this, right? So if we have some function, so let's say f1, right? So if we have this function here, right, f1. So what does this say? Okay, so this isn't like, we usually write functions like like what, f1 from int to int, right? And then we do something with it, right? f1 I equals I plus 1, right? And then, but the idea is when we use concrete types, right? Like int, string, list, int, etc. There are a lot of operations that are available.
Yeah.
On them, right? Because like we can add numbers, we can multiply, we can like concatenate strings, we can do a lot of, like, we can filter lists of ints and concatenate them and so on, right?
Yeah.
On the other hand, if we have a polymorphic type introduced via for all, right? The for all keyword.
Yeah.
We know nothing about it, so we cannot do anything. So actually, it's not that we can't do anything, but we can't apply any operation on them other than polymorphic operations, right? So what does this mean, right? So here, if I do this thing, f1 is this. I get an a as an input, right? Some a1, for example, right? Because like this is a type, so this is for all type a, right? It's a function from a to a.
Yeah.
But this, like, okay, so how do we read this, right? So for any type a, this is a function that takes a value of that type as input and returns a value of that type, right?
Yeah.
So if I take a value, okay, and it has to work for any possible type, right?
Okay.
So if I take an a1 as an input, right? And if I were to
Yeah.
say, well, I don't want to return, I want to return 0, right? Well, this is an error, right? Because what if I want to use this function for booleans, right? What if I do f1 true?
Yeah.
I get back 0, which is wrong because I need, like, if I pass true to the compiler replaces this with boolean because true is of type boolean, then replaces this with boolean and this is boolean, right?
Mm-hmm.
So actually, let me do this, right? So let me add some comments here, right? So now if I want to type f1 true, right?
Yeah.
The compiler will look at f and true and match them together, right?
Mm-hmm.
And it's going to be like f1 becomes like boolean to boolean, right?
Yeah.
Because true is boolean and f1 is polymorphic, right?
Yeah.
Because, for example, if we're trying to do a function that takes ints, then it would be an error, right? But because this is polymorphic, then it works, right? Otherwise, it would be an error if it wouldn't be possible.
Yeah.
Right? So then we have to return a boolean, but then what if it calls it with a value of int or a string or a list int, right? So the thing is, with this polymorphic type, there is only one thing we can do. It's just return it back. Like, we don't know anything about it, so there is nothing. So, okay. Since we know nothing about A, the only possible thing we can do is just return it unchanged. Right? We cannot do anything with it. Right? There's 0 things we can do. Let me give you a different example then. F2 for all A goes to A goes to A, right? So we have
Okay.
A1 and A2. What can we do here?
I can return something of A1, A2, right? But like, okay, so something A1, A2, like this.
Well, no, because I don't know anything about them. So I can do only one thing here. Well, I can do 2 things. I can return A1.
Oh, or I can return A2.
Exactly. Right. So let's do F2 and F2 prime, right?
Yeah.
Right. So in this example, we can pick either the first or the second input. We cannot smash them together, for example, using semigroup, because we don't know there exists a semigroup instance for A, right? Right? We don't know that, right? It might not exist. What if A is a type for which we have not defined a semigroup instance, right? Like int. Int doesn't have a semigroup instance, right? It's only the add one that has, like the add int, but not the regular int. Okay, so what if we do F3 for all A, B, and I say I take an A and a B and I return an A. What can I do here? Let's do A again. I can also just type A and B here, and it's like these are just variable names, right? It just so happens that this is of type A and this is of type B, right?
Yeah.
Okay, so what do you think I can do here?
Well, you can only return of type A.
Mm-hmm.
So you can only return A.
Okay, yes, right? That's correct. Is there any other implementation for this?
Well, not crossing my mind.
No, there isn't. It's a trick question, right? So there is no other. We cannot use B in any way, right? There's nothing we can do with the B, right? It's just not possible. Okay.
Okay.
So let's do a few more examples. So let's say for all A, B. Okay. What do you think? What can you do here?
Give me A, and I have to return. It returns B, right?
But there is no B, right? You don't have a B.
Yeah. So, I mean, this is the only one that.
But it's incorrect, right? Because A is not the same type as B. It's like another trick question. So this is not possible to implement.
Okay.
Okay. I want to give you a minute to think about it, right? Okay. So let's look at another example then. Let's do F5. So what if I give you an A, and I give you a function from A to B, and then I want you to give me a B back. So this is A, right? And this is a function.
Yeah.
What can you do?
Okay, just give me 1 second,
Mm-hmm.
please. So, I still feel like you can't do anything, and I mean, it's all from A to B. It's all up to the function. Wait, I think. Can I write it like this?
No. No, you cannot pattern match on functions. That's just an F.
Yeah. No, I was just doing it for my own
Oh, okay. I mean,
thinking. Yeah, but I don't know. Like
one other thing I sometimes do is I type this as A to B. When I have a function, I say a to b, but this is just a name, right? A to b, just so I remember that this is a function that takes an a and gives me back a b, right?
Yeah.
But then, like, you don't have a b here that you can type, so this is not right.
Yeah. So, is it another trick question, or is it like an A to B?
That's almost right, and it's not. I mean, it's a harder question than so far, but it's not a trick question. There exists a solution.
Oh yeah. In my head, it's the result of the function that gets returned.
But okay, so a to b is a function that takes an a and returns a b, right?
Yeah.
And we have an a, and then we have to return a b, right?
Yeah.
But if you return the function, then the result of this is a to b, not b.
Yeah.
So how do you go from this function? Like, this function is an a. Do we have an a?
Yeah, we do.
So why don't we just pass the a to the function?
That's what I wanted to do.
Yep. But again, you don't need the parentheses because this is not.
Yeah.
Right? So this is a lot like, you can think of this as type Tetris, right? Because like you can think of it, this is a lot like type, well, like Tetris, right? But with types. Right, so you can think of it like that, right? So for example, so let's see, how is that true? Well, like we have an A of type A, right? And we have an A to B of type A to B, right? Like this.
Yeah.
Right? So you're kind of like, okay, these are things that exist here that we have, and these are things that will consume them, right? So you can put the A inside this block, right? You can put, so A to B A is of type B, right? We can do this. Right, and what do we need? Well, we need a B, so we're done. That's what we need to type, right?
Yeah.
So usually when you implement functions that are very polymorphic like this, you kind of have to do this, kind of have to do this thing, right? Where, that's not an undo I was hoping to get. Right, you kind of have to look, okay, what are my inputs, right, is this and this. Can I combine them in any way by calling functions, right? And yeah, I can give this A to this function and get a B back, and voila, that's what I was doing, right?
Yeah.
So let's do another example of this. For all A, B, C. Okay, so I have a function from A to B, right?
Yeah.
And a function from B to C.
B to C. Yeah.
And I have an A, and then I want a C back. Can you write it? Okay, let me do F. Well, this is A to B, right? This is B to C, and then this is A. So what do we do here?
Okay, so I think, can I do it in steps?
Yep.
Like, first I get the A to B of A.
Yep.
And then the B to C. So.
Well, I mean, that's not really how the syntax for it.
Is it like this?
So okay, can you let's take a break for a second.
Okay.
So okay, we have an A to B here, right?
Yeah.
What's the result of A to B?
I'm sorry?
What is the result of A to B A? Like this thing.
It's B.
Okay, so then what?
I can replace it, right? I can just type B.
No, you can't. No.
Okay.
Okay, so let me show you the simple way to do this, such that you can actually do that. So there is this syntax where you can say let B equals to this, right?
Okay.
And then in, and now here you can use B here, right? Well, you delete this, right? But like you can use B here, right? So if you were able to use B here, what would you type?
It's B to C of B.
Yep, exactly, and that's correct. So this is like, do this, right? This will help you. Later, when you get used to this, you'll probably write it as B to C of A to BA. That's the same thing, right? Because like you see B here, and then you can just replace them, right? But for now, just do this, because this is great, right? If you get used to writing this, that's totally fine.
Okay.
Okay, so let's. And there's a method, there's a reason for this, because I think I want to show you how to, but anyway, try to write it from here.
Okay. So it's B of B to C. I mean, this
That's
is
correct.
yeah, but you know, of A. And well, and now I should let
Yep. So okay, what you can do? Okay, actually, yeah,
okay.
I'll let you type and we'll see. Well, that's not really right? Because B to C is kind of a function and C to D is another function.
Yeah.
So let me show you some extra syntax. So you can do something like, if you type this, if you go below B, you can also say C equals to something else.
Okay.
And I think you meant to type A here, right?
Yeah, yeah.
Okay. And then you can put the in afterwards here, right? So you can have as many as you want here, like one on top of the other.
Okay.
Are you sure it's C to D?
Wait. Okay, and then
aren't you? Wait, what? I think you typed something wrong here on the line on top.
Yeah, it's because of the autocomplete. Okay.
So it's B to C and then
Of
what?
B.
Okay.
And then I can also add the D here,
Sure.
which is the C to D of C.
But then you have to return something. So what do you return? What you put here at the end?
I mean, it should be C to B of C. Right?
But you already have it, right? So you can just type D here because you already have this.
Okay.
Right? So you can do D, or you can remove the last line here and then just replace this with C to D, C, right? It's the same thing. Okay. So let's go more complicated then. Well, I'll see these. Okay, you have one from A to B to C, and I give you an A and a B, and give me a C. Okay. Okay, what about this?
Okay.
Okay.
Is this the correct annotation?
Well, this you don't like AB is a single variable here. Okay, there we go.
Yeah. Okay.
Okay.
Okay. 1 second. Where C is equal to A to
Okay, continue. So far it's correct. But then, oh, wait, that's a function, right? So you just gave a different name to the same function. You have to apply some arguments to it, right?
Yeah. So.
Okay. Yeah, that's good. I think, was that an autocomplete here, or did you meant to type B to C?
No, I meant to type B to C. So.
But you don't have B to C here.
What? But I wrote B to C. No, I meant AB here.
Yep, correct.
Yeah. Okay. It's the autocomplete is messing me up. Okay, in, and this should just be C.
Yep. So I mean, in this case, you don't really need this, right? Because you can just type this, right?
Yeah.
It's like you don't have any intermediary results, right? It's just the end result. Okay, so like the trick, quote unquote, here is that you have two inputs, right? But you can just pass both of them at once, right? Okay, so let's do F9.
Okay. So I have to the A to B to C again of A to B.
You put space there. You put A space B instead of A to B. Didn't you mean to put A to B here because it's a function? There we go.
Yeah, I meant the A to B, but no, I meant A and B. But yeah, you're right. It's A to B.
Okay,
and only now it's A,
Mm-hmm.
B.
Where do you see the B here?
Oh, it's not. Okay.
And the result C, but you don't take that as an input. You just do
Yeah,
equals,
yeah,
right?
yeah.
Okay.
Okay. So I have to go for let again.
Yep.
I guess. But 1 second. Uh, wait. No. Is
But
this correct?
you don't
The
have a
first.
B, right? Where is the B? Because you don't have it.
Yeah.
But the question is, could you get a B somehow?
Yeah, it's A to B. So.
But then, okay. But then A
It's
to B to C only takes 2 inputs, and then you put 3 things here.
Would this work?
Yes, it would. Although I was expecting you to. Okay, and then you'd put in C, I guess, at the end, right? And that would be correct.
Yeah.
I was expecting you. So the thing that I was expecting you to do was okay. You would look here. Like, okay, I have a function that needs an A and a B, but I don't have a B, right? And I have this function. Well, with this function, I could say B equals A to B, A, and then I get a B, right?
Yeah.
And then I could have, okay, I have a C, so now I have this B here, right? So I can do this, and now I could say in C or something, right?
Okay. Yeah.
What you wrote is better because it terser, but well, that's not necessarily the case. But like it's better for you to see these things in step by step, right? Because you can think, okay, I have these 3 things. How can I combine them? Well, I cannot combine this here, right? Because like it doesn't work that way. I cannot pass this here, right? This is one thing, and this it's 2 different things, right? But I can put this A here, but then I still have this, so I cannot use it, right? But I can put this A here, and I get a B, and then I have an A and a B, and then I can get this and get my C, right?
Yeah.
Okay. That's the idea, right? But I want you to understand that this, what we've done here, is probably the most important thing that we've done so far. Because writing programs in Purescript and Haskell is very much something similar to this, right? You kind of look at, okay, what inputs do I have? What can I do with them? And then you somehow combine them to the result, right? It will rarely be this polymorphic, right? Some of these will be ints, some of them will be strings, some of them will be polymorphic, right? You'll rarely write something that is fully polymorphic like this, right? Where everything is polymorphic, which makes things hard because then you have a lot more things that you can do with things, right? Because as I said, here it's easy because the only thing you can do is just put this here, right? Or return it. That's all you can do. Just call functions, right?
Yeah.
Okay, cool. Yeah, I think this is what I wanted to show you, and then this means that we kind of talked about this sort of, but we also kind of talked about typing rules as well, because like that was the idea, right? What can we do with this, right? We can pass here, like if we have a function with like this, it needs 2 arguments, not just 1, and so on, right? This has to, and of course I understand that it's not natural, right? And it will take some time for you to understand, but I want for you to kind of try to remember this, right? When you type something, when you type code here, try to think about the types, right? Try to have this in your head and think, okay, this is a function that takes 2 inputs, so I need to write 2 things after it with a space in between, right? It needs to have this shape, right? Because like what you have to basically do is you have to kind of put a type Purescript compiler in your head, kind of, right? In a way, right? You kind of have to think like the language in a way, right? In order to be able to write this without like getting errors at every keystroke.
Yeah.
Right. So, yeah. So I think. Okay, so does that mean that we don't need this lesson anymore right now? Let me think. Can I do this plus this in one lesson? I think we can. Maybe we can. How important are the function instances? I don't think that much. Okay, so let me change this a bit.
Okay.
So let's say we've done the important bit of that. So let's do this. Let's do it like this.
Okay.
Because I want to do higher kind of types next time, and then functors, yeah. And then, okay, if we have time, we'll see. So this, the function instances, we'll see. We'll do it if we have time at some point. It might be, we might be able to do them just as like we did now this part, right? Okay, so now we can add a lot of homework about this part, right?
Yeah.
Implement. Okay, so let's see. I'll do H for homework, right? H1, H2, and whatever. Right?
Okay.
So let's see. Okay. Again, H1 equals to, and then it's up to you to figure. Well, I guess it's up to you to figure the inputs. I'll just not type the rest. You can figure the rest out. Okay. Okay. Actually, we're not going to have that many. I'm just going to write maybe a few more. We did const, we did identity. Give you an A and a B, and I'll give you an A to B. And it's okay. One thing here is usually, well, import. We want to try to use all our inputs when we write functions, right? Because, like, for example, in this case, if you have a look here, right?
Yeah.
You'll see that you have an A and a B, right?
Yeah.
And you have a function from B to C.
Yeah.
Right, so one possible implementation could be you can just call this function by passing B twice. Right, you put B here, you put the same B here, you get a C and you're done. But if you do that, you don't use this and you don't use this.
Yeah.
But if you use this and put this here, you get the second B.
Yeah.
Right, so usually when you see a function like this, it's kind of obvious that you need to put the A here, get this B, and then pass this like one B here and the other B here.
Yeah.
Right. And I wanted to type an example just so that you're kind of aware of this unwritten rule somehow. Okay. And then what else can we do here? Okay, let me use homework to teach you something else. So let's see, if A is a semigroup, actually no, if A is a monoid, and I give you a function from A to B, I want it to give me a B. And this, okay, can you guess what how this works? Because it's kind of like, if you remember, we defined this function here. Where is it? It was one of the first functions that we defined. It was this one, right? F5. So let me copy this and move it down so you can compare them.
Okay.
Right. So like it's similar to this F5 to H4, but it's missing the A, right? You're not taking the A as input.
Yeah.
Well, and I forgot this. Sorry. Right. This, of course, we need this.
Yeah.
Right. But instead of an A, we have monoid A.
Mm-hmm.
right? So can you guess what this is, like how this works, and if you can even implement it or not?
I just
Okay.
oh,
Okay. I'm not sure if you're getting cut off because I'm not hearing you talk. So I'm not sure.
okay, sorry. Okay. Moving the microphone closer.
That's better.
I'm I'm thinking, and
Well, no, because
it's
you
not
only have one
helping.
input right here. So this is the input, like everything that's after this, like fat arrow.
Yeah.
Right. So you only have this.
So,
You don't have an A here. So.
yeah.
No, so this is like, if you can guess, that's cool. But if you can't, I can show you because I've not shown you before. So.
No.
Okay. So the idea is, like, when you do this, it's kind of telling you,
Yeah.
okay, we know, like, for example, in all of the other examples, we knew nothing about A, B, and C, right? They were like no information. But in this case, we know that that A is a monoid.
Yeah.
Right? So in this case, you can do A to B empty, because we know that empty is a way to get an empty value of type A. Right?
Okay.
So even if we don't get an A explicitly, we get one implicitly because of this. Right?
Okay.
And then we can pass it to this function, then we can get a B. Right? So the idea is that if we have constraints, these are called constraints, right? This part here, or instances basically, right? Instances on type variables, then we can actually do more with them, right? It allows us to do extra operations. Which operations were the ones that are in this thing, right? In Monoid, for example.
Okay.
Right? And again, for example, let's see what other classes do we know. Something that actually makes sense. Let's see. I mean, let's give them names, for example, right? If we wanted to do increment, right, on a semiring A, how would you do this, for example? Can you guess? So what's increment, right? It's kind of adding one, right?
Yeah.
So you have, how many inputs do we have here?
I have one input.
Yeah.
So it's the A.
Yep, and then equals.
A equals A plus 1, but this is what. But I feel like it's wrong.
Yeah, because like if you look at this, if you hover over plus with your mouse, you will see that it's a semiring operation, and it's correct, right? Because we know it's semiring. But then 1 is an int, so we cannot do plus 1, right? We can do plus, but not 1. But let's look at semiring, right? What else is inside semiring? And you can look at our example with the extra like apostrophe at the end, like at line 96.
Yeah. So 1 is A. Right?
Yeah, but like we can use this function, the 1 function, instead of typing the number 1, right?
Yeah.
So here, like, you can do 1 instead without the apostrophe, because we're using the semiring without apostrophe, right?
Yeah. Like this?
Yeah, and then if you hover on top of 1, you'll see that 1 is a value of type semiring.
Yeah.
Right? And now this will compile and it will work, right? If we compile it. But then, like, if we type 1, we'll get an error saying, okay, 1 is not of type A0. And like, okay, when you see this sort of errors, you should know that Purescript adds numbers at the end of type variables, right? So it says A0, but it means A, right?
Yeah.
So this is the correct way to do it. Okay. Let me remove this, and then this is also example. So a few examples here, and then let's say this is a, what is it? Monoidal. So let's see, what other homework can I give you that kind of uses this idea? Okay, let's see. Oh, wait, what am I doing? Okay, and this will be homework. You'll have to figure it out.
Okay.
Okay. Yeah, this is also interesting. What else is interesting here? I think that's maybe enough. Yeah, that's enough. I think that's enough because this might not be very easy.
Okay.
Okay. I mean, right now you're getting errors, I think, because we have not implemented anything, right? And it's saying, oh, no, it's also because I mistyped this. Okay. And it's saying that you need to define it, right? The definition. And so
Yeah.
Yeah, I think that's enough for homework.
Okay.
So yeah, I think next time we'll do the like higher kind of types and functors.
Okay.
But like once we've done higher kind of types, we're kind of reaching close to the end of at least the beginner level of new language features, right? It's kind of like this is it, right? Types, recursive types, functions, type classes, records, and then like higher kind of types is kind of the last thing that complicates the language a bit. And then you kind of know all the language, and then we're going to learn a few more type classes, right? Functors, applicative, and monad are like one of the most famous type classes in functional programming, and one of the most used ones, next to the ones that we've done today, right? And then the rest will be, I think we can probably connect these lessons together, like these parts together. But maybe we can do it after we start building. Yeah, I think that's fine, probably. Yeah. Okay, yeah, so I think we have a plan for how to get to start building a simple program together.
Okay.
Okay, yep. Okay, cool. So yeah, so I think so after we've done this, and the fact is kind of like being able to actually run things, right? Read files, do something over network and things like that, right? Write to console, read from console, and so on, right? And after we learn how to do this, then we can start writing some simple programs. Okay, cool.
I'm not complaining.
No, I know, but it will be more fun to learn as we're building something, right? Oh, and also like, let me give you, because like, let's see, you have 3 weeks or 4 weeks for this. Think about something that you're like some program, some simple console program that you would be interested in writing. So let me give you some examples. So it could be like an in-memory database, because I've already started doing something like that, and we can do something like that together. It could be, for example, some console application to help you sort through whatever files you might have, like locally. Or it could be some program to call some API, right? For example, if you use, I don't know, whatever, I know, like Twitter or whatever sort of thing that might have a public API that we could play with. I know, think about like what sort of thing, because like it might be something that's even useful to you, or if not, think about something that might be interesting to you, right? A program that does whatever. If you can figure it out. If not, like if you don't get any idea, we'll brainstorm together. But yeah.
I'll think about it.
Okay, cool. Like if you get any idea, oh, it would be cool if this was a thing, right? If we could do this, right? And we'll see. Maybe like even if it's something complicated, we could maybe do a simplified version now for the first program, and then maybe we can work on it and make it better and better, right? It could even be something as complex as you want, right? It doesn't matter. You could even say I want to do a game. I don't care. We can do a very simple game probably, right? We can do like a guessing game, for example, the first example, right? And then we can do something more complicated and so on, right? So like think about any sort of program you'd be interested in, and then we can try to do at least a simple version.
Yeah, sure.
Okay, cool. Well, I mean, if you don't have any questions right now, then I think that's pretty much it for today.
I never have questions at the end. That it's just like
yeah, no, I can make sense that you don't, right? Because it's it's a lot to take in, right? Initially. So
yeah.
You'll yeah, I mean, again, if you have any questions even before next week, just message me anytime.
And again, sorry for this week, but it's been kind of hard.
No, don't worry. I mean, if you need a week break at some point, don't worry about it. Like it's absolutely no problem. Okay. Cool. Well, then I'll see you next. Oh, and next week will be earlier, right? We'll do 4 p.m. our time, which is 1 p.m. GMT.
Yeah.
Okay. Cool. Well, and I guess I'll see you next week for the early stream.
Yeah. Thanks a lot.
Okay.
Goodbye, guys. Goodbye, Vlad.
Bye bye.